Good day, Earth Science students. Welcome to video lecture episode 23. Today we're going to continue our discussion in the solar system. Remember last time we just talked about the two different models there were, the geocentric, which was the Earth at the center, and then of course the view that we are more familiar with today, and that being heliocentric with the sun being at the center. Now I'm just going to quickly review what's on slide 15 and then move forward from there. It says this: ideas about the solar system, modern view of the solar system. We now know that the solar system is made up of 9 planets, which includes the Earth and many smaller objects that orbit the sun. Now, if you had been able to see it in the textbooks that we had in class, but since we don't have them with us, but actually in the textbooks, Pluto was actually still classified as a planet in that textbook. Of course, we now know it today is classified as a dwarf planet, but it's still a planet nonetheless. Alright? Now, the 9 planets in the sun, if you look in most solar systems, you can see that. And like I mentioned before, in this textbook, it just happens to have Pluto in there. Now, if you look at the image on slide 16, you can see the sizes of the planets relative to each other. And you can see how small the planet Earth is compared to some of the other planets in the solar system, in particular Jupiter, Saturn. Alright? Now, the solar system also includes a huge volume of space that stretches in all directions from the sun. In other words, besides what we think about as our solar system, you know, the planets, stars, the sun itself, there's just a large amount of space. Okay? Now the sun, get this, the sun contains 99.86% of the mass of the solar system. So it makes up a huge portion of it. Now, let's talk about the sun. Because of its gravitational pull, the sun is the central object in the solar system. The size of it helps deal with that in particular. So all other objects in the solar system we're in revolve around the sun as a result. Scientists have hypothesized that the solar system formed from part of a nebula of gas, ice, and dust. Okay, that's one of their thoughts, okay? Which, of course, scientists have sought to illustrate how this works visually with computer models and such. Okay, now we're getting into a different discussion here. We're talking about just ideas scientists have about the formation of the solar system itself. Now, not all of the nearby gas, ice, and dust was drawn into the core of the cloud. The matter that did not get pulled into the cloud's center collided and stuck together to form what we know as planets and asteroids. Like I said, this is just talking about how planets form, what they hypothesize, alright? Now, close to the sun, the temperature was hot, and easily vaporized elements could not condense into solids. And this is why lighter elements are scarcer in the planets near the sun than in planets that are farther out in the solar system, because if they're closer to the sun, the temperature was hot, vaporized them, and they couldn't condense, versus if further away from that temperature, being cooler, and obviously the opposite happened. Now, let me talk about two divisions when we think about the planets in our solar system. They're the inner planets and the outer planets. The inner planets of our solar system are as follows: Mercury, Venus, Earth, and Mars. They're small, rocky planets that have iron cores. Then we have the outer planets. Which are Jupiter, Saturn, Uranus, Neptune, and Pluto, which Pluto is a small planet, and it's the only outer planet which is made mostly out of rock and ice. Just kind of connection here. So really the division in the solar system that we think of, or at least maybe you've heard of before, is you're either part of the inner planets or the outer planets, and there's distinct characteristics which of course set them apart. Now the other outer planets, not Pluto but the other ones, are much larger and made mostly out of lighter substances such as hydrogen, helium, methane, and ammonia. On slide 23 I actually have an image of representing those elements in case you were curious what those elements are. Well, let's talk about trying to integrate physics into this. Well, when Nicholas Copernicus developed his sun-centered model of the solar system, he thought the planets orbited the sun in circles. Alright? Well, in the early 1600s, a German mathematician, Johannes Kepler, began studying the orbit of the planets. Well, he discovered something. The shapes of the orbits are not circular. They're actually oval-shaped, or as we refer to, elliptical. His calculations further showed that the sun is not at the center of the orbits, but is slightly offset. Kepler also discovered that the planets travel at different speeds in their orbits around the sun. Now you can look this stuff up, and I'll try to see if I can post some information, or at least try to see if I can get the table from your textbook inserted in here. Now, by studying these speeds, you can see that the planets closer to the sun travel faster than the planets farther away from the sun. So the closer they are, the faster they travel. Alright? Now, because of their slower speeds and the longer distances they must travel, the outer planets take much longer to orbit the sun than the inner planets do. In other words, we know a year here on Earth is 365, and that varies whether you go closer to the sun on other inner planets, or you go further out to the outer planets, which is pretty interesting to think about. Now, Copernicus's ideas, considered radical at the time, led to the birth of what we know as modern astronomy. Early scientists didn't have technology such as computers and space probes to perform rapid calculations and learn about the planets, but their work was huge, and we really have to thank them for it. Nevertheless, despite not having the technology, they developed theories about the solar system that are actually still used today. It's pretty amazing when you think about it. Alright, ladies and gentlemen, we conclude our lecture here. If you have any questions, you can leave them in the comments below. Send me emails. Have a nice day. Take care, students. Goodbye.